Now we'll study the control for interrupt. Interrupt enable register carries out the control for the interrupt. The structure of it is shown here. We know that at critical times the program must be able to inhibit the action of some or all of the interrupts so that the crucial operations can be finished. The interrupt enable register, that is nothing but the I register bits, can enable or disable all the interrupts as a group, or if the group is enabled, each individual interrupt source can be enabled or disabled. Bit in the I register are set to 1 if the corresponding interrupt source is to be enabled, and set to 0 to disable the interrupt source. For example, see the bit 0 of this register, it is EX0, and the EX0 means enable the external interrupt 0. Whenever it is set to 1 to enable INT0 interrupt, and it is clear to 0 to disable the INT0 bar interrupt input. Similarly, ET0 is associated with the timer 0 internal interrupt input. EX1 is associated with the external interrupt input, that is INT1 bar. ET1 is associated with the internal timer interrupt input, that is timer 1. Then comes the ES. The serial communication can be enabled or disabled by clearing or setting this bit, that is ES. 82 is reserved for the future use. And very important, the bit 7 of this IE register, EA, that is enable interrupt bit. All these interrupts can be enabled or disabled by setting or resetting this particular bit. If it is clear to 0, then it will disable all the interrupt inputs, internal as well external, and when it is set to 1, then all the interrupt inputs are enabled. Based on the requirement, particular bits can be set or reset so that the particular interrupts are enabled. Suppose I require in my system only the timer related interrupts to be enabled, then the bit 3, that is ET1, and bit 1, that is ET0, will be set to 1, and all others can be set to 0, so that only the timer related interrupt inputs are activated and all others are deactivated. Now we'll study the priority for the interrupts. The structure for interrupt priority register is shown in this figure. Often it is desirable to be able to set priorities among the interrupts that may occur simultaneously. The interrupt priority register can be used by the programmer to assign priorities so that more interrupts can be serviced. The default priority for all the interrupts is in this way. Very first is I0, second is TF0, third is I1, fourth is TF1, and last is the serial, that is RI or TI. The meaning is that the external interrupt input INT0 bar is having the highest priority, which is followed by the timer 0 internal interrupt, then the external interrupt 1, that is INT1 bar, then the timer 1 internal interrupt, and the lowest priority is assigned to the serial communication related interrupt. IP register bits determine if any interrupt is to have a high or low priority. Bit set to 1 gives the accompanying interrupt a high priority, and 0 assigns a low priority. Interrupts with a high priority can interrupt another interrupt with a low priority. The low priority interrupt continues after the higher is finished. The serial interrupt, as we know, in the default structure is having the least priority. So it can be set, its priority can be set to high, that is it can be given the highest priority by setting the PS bit in the IP register to 1 and clearing all the other bits. Here you can observe bit 0 is PX0, which will assign the highest priority to the external interrupt 0, that is INT 0 bar. Similarly, if you set PT0, it will assign the highest priority to the timer 0 overflow interrupt, and accordingly you can assign the highest priority to one of the interrupts, one of the 5 interrupts. Now we'll see the interrupt destinations. Each interrupt source causes the program to do a hardware call of the dedicated address in the program memory. It is responsibility of the programmer to place the routine at the address that will service the interrupt. The interrupt saves the program counter on the stack. The interrupt saves the program counter of the program which is running at the time the interrupt occurs on the stack. A call is then done to the appropriate memory location. These locations are given in the following table. The interrupt I0 is having the default location 0003H. TF0 is having the address 000BH. I1 0013H, TF1 001BH,